The GEOGloWS Partnership is organized under GEO, the Group on Earth Observation, and specifically focuses on global water sustainability and bringing together some of the world leaders in NASA, NOAA, ECMWF, ESRI, and the World Bank in order to develop tools that can provide a forecast on every river of the world every day. The GEOGloWS ECMWF Streamflow Services is a hydroinformatics tool that allows big data, computational resources that are used at ECMWF for a global model to be able to be downloaded, accessed locally on every river in the world. It provides a 40-year simulated historical data set that gives insight into hydrology where none existed before, while also providing a 15-day ensemble forecast on every river in the world.
Flooding really devastates neighborhoods. A global partnership enables local partners to concentrate better on their job, and therefore I think it's quite important in solving the problem of flooding, which is a global problem.
Brigham Young University Hydroinformatics Lab is fundamental or key in the development of the flagship tool, the GEOGloWS ECMWF Streamflow Forecast Services. Using the Hydroinformatics, Tethys platform and other tools that have been developed here, we've been able to bring these sciences together and create an application that delivers global information, big data, to local water resource managers so that they can make better decisions.
The role of academia is vital for this type of partnerships because they provide solutions through research and innovation. Brigham Young University has been our academic leader. Researchers at BYU have developed new and innovative techniques to downscale and visualize streamflow information so that governments at national and local level can uptake and utilize this streamflow forecast.
SERVIR's tagline is Space to Village, and through workshops, capacity building, really relationships with the people, by the people in the regions, all of our hubs are from the regions, we're able to really reach the local users. SERVIR brought its resources, GEOGloWS brought its resources, and together we were able to work with the contributions of BYU in bringing global streamflow prediction tool down to the regions and then back up to the global level as we learn something more locally.
One of the efforts of GEOGloWS is to be able to provide data to developing countries in places where they have little. BYU has a mission that the world is our campus and that we enter to learn and go forth to serve. And GEOGloWS provides a perfect platform for us to be able to go out and make that kind of difference globally.
The BYU Hydroinformatics Lab research has been a great benefit to the students in our department. So there's always been a big focus at BYU on making a difference in the world and having an international outreach. And the laboratory has been very fortunate to be involved in a number of international activities with a significant global reach and in ways that have actually changed the way people manage hydrologic data.
The benefit has been that now I consider the hydrology as a global problem instead of considering it as a local problem. And that point of view helped me to understand problems that we have in the water management, and these problems that only can be managed by global models like the GEOGloWS project.
The GEOGloWS project has shown me that people all over the world have the same needs. Water is very important. It can be damaging with floods, but also people need it to survive, and so being able to provide that information to other people and realizing that we're all kind of in the same boat and we need the same things has been a good impact.
My role in the GEOGloWS project has been building a series of apps and coding tools that help the end users interact with our model and get information that they need. I've really learned what kinds of things I take for granted in the United States and what kind of information would be useful for me to provide to people around the world. It's really opened my perspective and expanded my horizons on these kinds of hydrologic issues.
It takes them out of the classroom, out of the laboratory, and puts them in an entirely other setting where they are experiencing modeling and simulation and applying it in places around the world where we can make a difference. And I think those kinds of experiences are invaluable for graduate and undergraduate students.
Our research in our laboratory has ranged from groundwater modeling, groundwater sustainability and analysis, streamflow and flood prediction and forecasting, geospatial data models, and cyber infrastructure to support water resource analysis.
We have a long history of developing visualization and data informatics tools for water resources. Combined with the students that come here that have a lot of international experience through the missions that they've served and through the international nature of our graduate research students, we're able to contribute and solve problems around the world.
This is something which is really game-changing because we believe that with better training, especially with local data sets, you can make these into services that are operational and leverage this new world of open APIs that are accessible to everybody and make them part of their national information systems for water as well as for their forecasting systems, and to better manage the water infrastructure in terms of operating dams and irrigation systems in a systematic way based on these types of data services that are now accessible.
The GEOGloWS Partnership is what has made this entire project possible. The funding that we have received and research support is important, but the partnership between NOAA, NASA, ECMWF, the World Bank, and ESRI have really provided the impetus and the opportunity to use our tools on a global stage and make an important difference around the world.